Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In previous video, we have discussed about output devices like graphics displays, sound displays and haptic feedbacks, and some of the applications of graphics and sound displays. And again, we are going to discuss about the output devices applications in virtual reality. Okay. Here we have one more type, floor supported displays. Here we have flow like rendering, view calculation, forward kinematics, conversion and STD bugs. Here the input is analog data, and finally we have left and right graphic images. From analog data to STD box, we have raw joint values. After that we have conversion and floating point angles. After that we have forward kinematics, and which can be interlinked with in linkage and viewer matrices, and we have view calculation, and finally we have left and right viewing matrices. And the final part is rendering, which gives left and right graphics images with the help of parallax theorem. Okay, see here the example of virtual window 3D display. Here we have a virtual window 3D display, and here in this we have counterbalanced and no dead space but high latencies due to third-party tracker. And out of stereoscopic displays we have a passive, also active, and it do not require the use of special glasses. Passive autostereoscopic displays do not track user's head and thus restrict user's position. Active autostereoscopic displays track the head motion and give more freedom of motion. See here, passive autostereoscopic 3D display. Here we have an example for passive autostereoscopic 3D display. Here we have light lines and liquid crystal display, LCD display. Also we have light lines aligned with respect to our human's visual axis. And this is our example for LCD display with 20-inch LCD display with a resolution 1600 x 1200, and here the height is 1.5 to 6 feet and weight is 8.4 kg. Again we have 18-inch LCD display for example. Here the resolution is varies 1280 to 1024, and we have a mono it is 1280 with 1024, and in stereo we have 640 x 1024 and the weight is 17 kg. Before that we have a 20-inch LCD display. Here the resolution is 1600 x 1200 mono, and we have 100-inch horizontal viewing. Okay, here the weight is 8.4, here the weight is 17 kg. And next we'll move on to single user autostereoscopic display. The display redirects the appropriate frames to the right and left eye so that each eye can only see the relevant frame. The tracker locates each eye and sends the information to the control box. The control box then tells the LCD screen what pixels to display. Through the optic systems in the screen, the image will get directed through the TFT directly to the appropriate eye. A split second later, it would be do the same to the other eye, hence creating 3D image. See here. Here we have TFT flat panel display. We have RGB subpixels, eye finder and stereo cameras. And in the tracking unit we have engine control, stepper motor, and finally we have both the eye visions, left eye as well as right eye. Here the active tracking accommodates plus or minus 25 degrees changing in view direction. Okay, in this output devices we have discussed about displays, output displays like our haptic displays, graphics displays, sound displays, and haptic feedback and haptic displays. We have some more applications. We'll see that in next video. And in this previous videos, output devices part 1, part 2 and part 3, we have discussed about what is display, what is the use of display in virtual reality, and types of graphics displays, sound displays, and applications of graphics as well as sound displays in virtual reality applications. Okay, thank you.